Hello everyone, my name is Francisco Gancino and welcome to my poster video about the structure and optical behaviors of the small nickel cobalt nanoparticles fabricated by jet combustion. As we know, the transition metal oxide have around much interest owing to the potential applications for catalysis, storage energy, electrochemical, and biomedical. In fact, the nickel cobalt has one of the typical binary transition metal oxide has attracted a considerable attention in these fields. The nickel cobalt nanoparticles belong to the spinel oxide family. Exists a remarkable interplay of the chemical composition and crystalline structure. This gives rise to exceptional characteristics, including high surface area, enhanced electrical conductivity, and intriguing magnetic behaviors. Such attributes have propelled nickel cobalt nanoparticles into the forefront of various scientific endeavors. Therefore, in this poster we present a nickel cobalt nanoparticle synthesized by low-cost jet combustion method. The nanoparticles have been studied by X-ray diffraction, scanning electron microscope, EDS technique, and optical spectroscopy to evaluate the possibility of applications in catalysis. In this part of the poster, we can see the combustion method used to the nanoparticles. First, we prepare the solution with the precursors of nickel cobalt nitrates to dissolve in deionized water. The solution was heated to evaporate the water to form the gel. After that, the gel was steamed at 450 degrees during 6 hours. The solid product was used to characterize for the mentioned techniques. In this part, we can see the typical scanning electron microscope micrograph of the samples. The micrograph reveals the formation of the nanoparticles in a pseudo-spherical shape around 50 nanometers. Also, we can see that the atomic radius of the nickel cobalt we found to be nearly 1 to 2, which indicates the formation without impurity phase, such as nickel oxide or cobalt oxide. We realize the diffuse refractive spectroscopy of the sample to use the Kugelka formalisms, and we present the estimated optical bandgap energy. As we can see in the figure 2, the Kugelka Moon plot reveals two values of the bandgap energy, which can be associated to the coexistence of the cobalt 3 plus with high spin and low spin states in the spinel structure. Now, in this part of the poster, we can see in the figure the room temperature X-ray diffraction patterns, for example. Um, the peaks of the X-ray diffraction patterns match perfectly with the standard peaks position of the nickel cobaltine spinel structure. However, we can observe that the formation of the nickel cobalt oxide in relation 1 to 1. On the other side, we can observe the absorption and desorption isotherms which correspond to type 2 owing to the absorption and desorption branch almost coincide. Therefore, we use the BET method to determine the surface area and the pore volume of the sample presented in the table inside in the plot. Finally, with these results, we conclude that the synthesis by jet combustion method permit to obtain small nickel cobaltine nanoparticles with high potential to application in catalysis due to the surface area, the coexistence of the two spin states, and low-cost method used to fabricate. So, thank you for your attention. It will be a pleasure answering the question. In the poster, you can find my email.